Welcome to another fantastic session brought to you by Learning to Lead. Life is a school of probability. In this session, we will review basic concepts of probability and statistics. Probability is the likelihood that something will occur. For example, if you have a tire with low pressure and you don't fill it, there's a high probability that you will eventually get a completely flat tire. If you don't study at all for your history test, there is a high probability that you will not get a favorable grade. Let's look at the concept of simple events probability. For example, when flipping a coin, the probability of getting a head or a tail is 1/2 or 1 out of 2. The probability of getting a 2 in a single toss of the die is 1/6 or 1 out of 6. Compound events are formed by 2 or more events. Compound events probability combines at least 2 simple events. The probability that a coin will show heads when you toss only one coin is a simple event. If you toss 2 coins, the probability of getting 2 heads is a compound event. Let's look at an example. Your friend tells you, "I will give you $100 if you flip 2 coins and they both land on heads." Let's see what happens when you toss the 2 coins. What are the different possible outcomes when flipping 2 coins? Well, you can get 2 heads, a head and a tail, 2 tails, or a tail and a head. Therefore, the probability of getting 2 heads is 1/4. You have a 25% chance of getting that $100 your friend said that they would give you if you got 2 heads when flipping coins. Now, let's look at the complement rule. The complement rule states that the sum of the probabilities of an event and its complement are equal to 1. For example, if the desired outcome of flipping a coin is heads, the complement is tails. Suppose you know the probability of getting the flu this season is 0.43. The probability of A getting the flu is written as P of A, which equals 0.43. The complement, therefore, is not getting the flu. So the complement is 1 minus the probability of getting the flu, which is 0.43. Therefore, your probability of not getting the flu this season is 0.57. Let's talk about conditional probability. Conditional probability is the probability of an event A happening given that another event B has occurred. The formula for this is the probability of A and B divided by the probability of A. For example, what is the probability of getting your paycheck on a day that it's raining when you live in Seattle, Washington? Here is an example. If we have an urn that contains 3 white marbles and 2 black marbles, what is the probability that the first marble drawn is black? The formula is 2 divided by 2 plus 3, which equals 2/5. The 2 in the numerator represents the probability of getting at least 1 black marble drawn from the urn. The 2 plus 3 in the denominator represents what is currently in the urn, 2 black marbles and 3 white marbles. Let's say that you drew a black marble on your first try. What is the probability that you will draw another black marble? The formula is 1 divided by 1 plus 3, which equals 1/4. The 1 in the numerator represents the probability that at least 1 black marble is drawn. 1 plus 3 in the denominator represents what is currently in the urn, 1 black marble plus 3 white marbles. Finally, what is the probability that both marbles drawn from the urn are black without replacement? We take 2/5, which is the probability of 1 black marble from the first draw, multiplied by 1/4, which is the probability of drawing 1 black marble from the second draw, and we get 2/20, or 1/10. Let's look at one more example of conditional probability. In a card game, the player has to draw 2 cards of the same suit to win from a standard deck of cards. On the first draw, the player draws the ace of hearts. What is the conditional probability of drawing a second heart? The probability of drawing a second heart is 12 over 51. Union and intersection. The union of two sets is a new set that contains all of the elements that are in at least one of the two sets. This is written as A union B. The intersection of the two sets is the set of all distinct elements that are in both A and B. This is written as A intersection B. Mutually exclusive means that two events, A and B, cannot occur at the same time. For example, you cannot have your car in park and drive at the same time. Those are mutually exclusive events. However, you can own a cat and have peanut butter and jelly for lunch. Owning a cat and having peanut butter and jelly sandwich for lunch are not mutually exclusive. Let's do a math review and review factorials. In math, the factorial of any positive number n is denoted by n followed by an exclamation mark, or n factorial. The factorial is the product of all positive integers less than or equal to n. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which equals 120. The value of 0 factorial is 1. To use your calculator to determine factorials, let's review this example. To calculate the 5 factorial on your calculator, press the 5 button, then the second button, then the x factorial button, which is actually the 3 button, and then the equal sign. It's much faster doing it this way than calculating longhand. Permutations and combinations. Permutations are how many different arrangements can be created from a group. Combinations ask how many different groups of people or items can be chosen from a larger group. Here is a permutation example. In the ugliest dog competition, a blue ribbon will be awarded to the ugliest dog, a red ribbon to the second ugliest dog, and a yellow ribbon to the third ugliest dog. If there are 8 dogs in the competition, how many different ways can the ribbons be awarded? This is a permutation question because order is important. We are not only choosing 3 dogs, but the order in which they are arranged makes a difference. This example is a permutation of 8 choosing 3. You will be using the NPR function on your calculator. Select the 8 button and then the second button. Select the NPR button, which is actually the 9 key, and then the 3 button. This equals 336. There are 336 ways the ribbons can be awarded. Now let's look at a combination example. Chris wants to take 3 dogs with her on her morning walk. If Chris owns 8 dogs, how many different groups of dogs can she choose for her walk? This is a combination question because order doesn't matter. When Chris chooses the 3 dogs, the order in which she arranges them doesn't matter. This example is a combination of 8 choosing 3. You will be using the NCR function on your calculator. Select the 8 button, then the second button, NCR, which is the 8 key, and then the 3 button. This equals 56. There are 56 different variations of groups of dogs Chris can choose for her walk. Let's review mean, median, mode, and range. The mean is the average of your values. The median is the value in the middle. The mode is the most frequent value, and the range is the difference between the lowest and the highest value. Remember the bell curve in school? That is an example of a normal distribution. What does the mean look like on a normal distribution? The mean's right in the middle of the distribution. The standard deviation measures how far you are away from the mean. Population and sample. There are different notations for population and sample mean and size. The population is your entire data set. All of the apples in an orchard would be the population. The population mean is noted as mu, and the capital or uppercase N is used for the population size. A sample is a portion of the population, like these 4 apples in the basket that were picked from the orchard. The sample mean is noted as x bar and the sample size is a lowercase n. Here are the formulas for population and sample standard deviation. Note that the sample standard deviation outcome provides us with an estimate of the standard deviation of the population from which the sample was drawn. You can use the formula, or you can calculate the mean and standard deviation for a sample and population on a calculator. Let's look at basic distribution types. A normal distribution is where the mode, median, and mean are all the same. In a negatively skewed distribution, the mode is greater than the median and the mean. In a positively skewed distribution, the mode is less than the median and the mean. The central limit theorem states that as the sample size n gets larger, the distribution becomes almost normal regardless of the shape of the population. If you enjoyed this video, please click subscribe to be able to see the latest videos from our YouTube channel for Learning to Lean. Thanks for joining me in today's session. Information on additional sessions can be found on our website, learningtolean.training.